Good morning, YouTube. What's up, everybody? And we are continuing our commitment to solving Khan Academy SAT math problems. And we're actually in the last section. We're in the additional math topic section for Khan Academy. So we're almost all the way through. We've solved problems from each and every section. And by the way, when this completes, I'm more than happy to take requests if there's particular problems you want to see solved or different things you want me to look at. I'm more than happy to do it. But today it's going to be fun. We're looking at volume word problems. Volume can be pretty interesting and kind of fun and actually have a lot of real-world applications. So without further ado, let's get into it. We're going to jump right in today to the screen share. It's a little early, but it's not too early. It's all good. Volume word problems. And as always, we're looking at these for the first time. So I'm solving them right with you, which is pretty fun. And if you're watching on Instagram, make sure to check out my live stream on YouTube so you can actually see the problems, see the screen share, solve them along with me. Go to YouTube, search for Scalar Learning, and you can find everything there that you need to prep for the SAT. All right, here we go. Question 1. Cam is making a party hat shown at left in the shape of a cone for his birthday. The circumference of the part of his head where the hat will rest is 56 centimeters. So this length right here, let's see, 56 centimeters. This guy, right, this circle has a circumference of 56 centimeters. If the height of the hat is 25 centimeters, so this height right here coming down is 25 centimeters. Which of the following is the closest to the volume? All right. So you just got to know the formula for volume of a cone. So basically what you do is you multiply, I believe, I'm kind of going off memory, but I believe it's 1/3 height times circumference, which is, I'm sorry, times area, actually. Wait a minute, we need area. Why do they give us the circumference? So we're gonna have to convert that to, this is taking a little bit of calculation. So what we need, and I'm gonna double check the formula even before I submit my answer. I'm pretty sure it's 1/3 height times pi r squared, right? Because we need to measure the volume, pi r squared. Okay, so if the circumference 2 pi r equals 56, we can figure out the radius by dividing both sides by 2 pi, right? This is the formula for circumference, and that's what they give us. So the circumference up here is this formula. So 56 over 2 pi equals the radius. So now we can say radius equals 56 over, I'm going to do a little bit of estimation. Again, this is a calculator, but I'm just not going to use one if I don't need to. So we're going to divide it by 2 pi, which is about 6.2, let's say 6.3, 6 really, but so let's say 6.3. So let me do a quick estimate. And again, you can use your calculator if you want. I'd say it's about 9. So the radius is approximately 9. I'm doing this because I see such a wide margin, by the way, in all these answer choices. They're not super close together. Otherwise, I would, and yes, I really do love math. Thank you for noticing. Otherwise, I would use a much more precise estimate, but I'm just kind of winging it. So this is what's happening here. Now let's go over here, and we're going to plug in everything. 1/3 times our height, which is 25, times pi times 9 squared. So we're plugging everything in, right? The 9 goes here. So what's 9 squared? That's 81 times 25, 1/3 times 25, and then we still got a pi here. I can multiply the 1/3 times 81 because that's divisible by 3. So 1/3 of 81 is actually 27. So 27 times 25, right? And then times pi. So let's do this really quickly. 25 times 27. There's a lot of work here. I would not do this on the real test. I would use a calculator, right? But as I've mentioned before, I always like to keep my math skills sharp. 4, 5, 5, 7, 6. And then we're going to multiply this by, let's just keep it simple, 3.1. 5, 7, 6, 0, 15, 21, 22, 18, 20, 5, 2, 8, 9, 0, 2. And we got 1 decimal. So look at this. I got a pretty close estimate here, and I got about 2092, which is clearly going to be closest to this guy, 2080. So I think that's a pretty good answer, 2080. So we'll go back and we'll answer this. You know what? Let's just go for it, and let's see what they say. Okay, so it is right, and I did get that formula right. I was pretty sure that was the formula for the air for the volume of a cylinder. It is 1/3 pi r squared. So that's the gist of it. You just got to know the formula. All right, let's move on to the next one. Here we go. Let's clear the board, and let's take this guy. Question number 2. A set of 3 cylindrical canisters all have diameter of 8 centimeters. The heights of the canister, so we got 3, 2. All right, big into drawing these geometric problems always. See this? Here's my cylinders, kind of like cans of Coke, right? Okay. And they all have a diameter of 8. So we're going to try and say it's across as 8 centimeters for all of these. It's all the same. The heights are different. So the heights are 16. Let's see. I'll just make it like this: 16, 12, and 9. Which of the following is closest to the total volume of the 3 canisters in cubic centimeters? Okay. Volume of a cylinder. It's actually an easier formula. I like to think about it like this. I like to think we're calculating the area of a circle, and then we extend it across the height. So it's like we calculate the area of this top circle, right? And then we kind of extend the circle down the height and fill up this can, and that's volume. So it's literally pi r squared, which is the area, times height. So we just got to do that for all of these. Now we can do it sort of estimation style again, because look at these nice differences. They're pretty far apart. I'd say they're pretty far apart, right? You got 804, then they're separated by 200, then 800, then almost like 6,000. So let's give it a shot here. So first we can say, whoops. So this first one would be 8. Sorry, let's not do it this way. Let's say 16 times pi, and then r squared is r squared. All of these is 4. It's half. The radius is half of the diameter. So 4 squared. This next one is going to be 12 pi 4 squared. And this next one is going to be 9 pi 4 squared. And we're just going to add them up because they want to know what's the total volume. We're going to add these guys. So 16. So this one turns into 16, right? 4 squared is 16. So we're going to multiply the 16 and the 16, which I just happen to know is, I believe it's 256. I'll double check though. 36, 6, 9, 0, 6, 1, 6, 5, 1. Yeah, it's 256. So 256 pi plus 16 times 12 is 192, plus 192 pi plus 16 times 9 is 144 pi. And now we can add all this up. 256 was 144. These guys, see, I'm doing this the shortcut way. I mean, the way that I think is fastest, right? 256 pi plus 144 pi is 400 pi plus 192 is 592 pi. So you can use a calculator again for all of that. And you can use a calculator for this next part. 3.14 times 592. But guess what? I'm just going to do it by hand. I already know it's 1860 because this is about 3 times 600. It has to be about 1800. Nothing is even closer, but let's just do it for fun. 2, 9, 5, 0, 6, 7, 17. 15, 17. So 2, 5, 1, 12, 13, 1, 18, 1. We got 1 decimal. 1835. Okay, 1835.2. This is clearly the closest. So let's go. I hope that made sense. Let's go to C. Let's give it a shot. Yes, it is right. Right. Did the same thing. Power squared H. Exactly. Let's check question number 3. Goodbye. Here we go. This is nice and big, so let's try this. I'm going to change the color back to black. A cake pan is in the shape of a right rectangular prism, 20 centimeters. What's a right rectangular prism? It's like this. It's a box. That's all it is. Right rectangular prism box. Boom. 20 centimeters long, 20 centimeters wide, okay, and 5 centimeters high. Boom. The pan contains 1,000 cubic centimeters of batter. Approximately how far is the cake batter from the top of the pan? Well, all we need to do is, I see. This is an interesting question here. This is very interesting. So we have to think about it like this. All right, this is a little crazy. So we first need to figure out the total volume of this whole thing. Total volume is just length times width times height. Simple, right? And I can do it mentally as well. You can too. It's just, first we'll multiply 5 times 20, which is 100. And then we multiply that times this. What's 100 times 20? It's 2,000 cubic centimeters. So if 1,000 cubic centimeters is in here, that means this guy is filled halfway. Right? Filled halfway. So this is where it's at. Well, if it's filled halfway, it must be halfway to the top. And so if the height is 5 centimeters, it's got to be halfway. It's got to be 2.5 centimeters from the top, and that's it. See, you can kind of reason that one out. It's really important when you take these tests and look at these questions, you don't get intimidated. This can seem crazy. It's like, I don't know the formula to calculate height of remaining volume. You might think that. And I don't know, maybe there is some formula that you could use and plug in, but you don't need to. It's just like you take a step back, you look at the problem, and you can use logic a lot of times to fill in whatever gaps maybe there as far as memorization, rote memorization. Question 4 or 5. A household aquarium tank is in the shape of a rectangular prism. Nice. Another rectangular prism. We now know what that is. Let's do it like this, like this. And it has a rectangular prism, has a base length of 24 inches and a base width of 15 inches. The height of the water is 12 inches above the base. So let's just say there's some water in here. And this height is 12 inches. Let me just put a blue thing here so we can see. That height is 12. Okay. During cleaning, 900 cubic inches of water is removed. What is the absolute value of the change in the height of the water in inches? Well, let's first look at, this is, again, kind of like the same thing. Let's first look at the height. I'm not at the height. We know the height is starting at 12. Let's first look at the volume. So we have to just multiply these guys, length times width times height. So we try and do it in the easiest way possible, because I'm going to try and do it not using a calculator. Calculator, you have it done in a second. So 12 times 15 is 180 times 24 is 24700. 16 1 2 3 0 2 3 1 4 4 320. And then 900 is removed. Did I do that right? Let me just double check. 0 32 2 carry 3 4 7 0 0 16 1 2 3 0 2 13 1 4. Yeah, okay. And then 900 is removed. Okay. 900 is removed. And now we have 0, 2, 4, 3. So we have 3420 left. Okay. So what is the absolute? Sorry. What is the? It just says what is the absolute value of the change in the height? Right. Okay, never mind. We actually so now we're down to 3420, and now let's figure out the new height. So 3420 is the volume equals x some new height times 24 times 15. Okay. So now let's do this multiplication. We do one time. Let's see. I'm going to try and do it in my head. So 240 plus 120 is 360. Right? 240. Did I do that right? 240 plus 120 is 360. Yeah, equals 3420. So x is our height. So if we want to divide by 360 now, we're going to get the height of this new whatever, like of 3420. Then eventually we'll get the difference. So 3420, let's do it out here. And this can just be 342 divided by 36. Let's see, 10, 9. It's not going to be exact. Wait, see, this isn't exact. Let's see, 270 plus 54. 324. Let's see, 3, 1. So it's 8, 1, 18, 180 times 5. Okay, 9.5.0. So again, you don't need to be doing this. You can do this on a calculator. It's a calculator problem. Anyways, the new height is 9.5. So it goes from 12 to 9.5. And they want to know what is the absolute value of change. So what does it drop by? Right? It drops by 2.5. 0, 11, 2. So the absolute change in water in inches is 2.5 inches. Wow, that was an involved question. That was pretty hard. Let's see if this is right here. Yeah, it's right. Okay, excellent. So that is how you do that problem. Tough one. Long one. Okay, finally, let's do question 5 of 5. This is a no calculator section. Perfect. My favorite. And here we go. Question 5 of 5. And when I do these calculator ones without a calculator, I must say, if I were to take this on a real test, though, I would use a calculator for sure. It's a waste of time otherwise to not do. I mean, it may not even be a waste of time, but it's just playing with fire. You never know. Dye is created by smoothing the corners of a plastic cube and carving indented pipes. And the original cube had an edge length of 2 centimeters. Okay, here's my cube. 2 by 2 by 2. The volume of the final dye is 7.5. What is the volume of the waste generated by creating the dye? What are we doing? We're just taking the difference, right? What's the volume of the original cube? Length times width times height, right? Because we only need one edge length for a cube. They're all the same. 2 times 2 times 2 is 8. The new cube after the changes is 7.5. The waste is the difference. What do we lose? It's just 0.5. That's it. 0.5 centimeters cubed, which is the same as 0.5 milliliters. Yes, it is correct. So that's it. Let's go back to non-screen share. All right. So we just did volume word problems. Those were pretty tough, actually. A couple of them. The last one wasn't too bad. It was pretty straightforward, but those can get tough. So I hope you enjoyed. If you guys have any questions, email me at huzaifa@scalarlearning.com. But more importantly, make sure to comment below if you have a question. I'll be happy to respond to it directly. And if you haven't done so yet and you enjoyed the video, please like it and subscribe, of course, if you want more SAT Khan Academy problems straight to you, plus all sorts of other math resources. Thank you guys so much for joining. I know it's early, but I hope this was helpful. I hope you have a great rest of your day. Take it easy.